Hello, my name is Partha Varanashi. I was born in an organic farm, it's the Varanashi Organic Farms, to two agriculture scientists, Dr. Ashwini Krishnamurthy and Dr. Varanashi Krishnamurthy. I studied agriculture biotechnology at the University of Adelaide in South Australia, and I've come back and I've been living in Varanashi farm since the last decade. We research on soil microbiology and development of sustainable agriculture in this area, and also we do consultancy work and also produce biofertilizers and organic manures as a organic farming input, supporting the farmers from our area and around India. Thank you. Welcome to Varanashi Organic Farms. My name is Partha Varanashi. Varanashi Organic Farms has been organic farm since the last 30 years. It's a heritage farm with over 200 years of history. We grow multiple crops here. We also do animal husbandry and also do research on sustainable farming. And let's just talk about what plants need in order to get a high yield. Okay, so as farmers, we're always looking for higher yields. At the same time, we are looking at lower carbon footprint and more sustainable ways of developing a farm. Now, when you see scientifically what plants need to grow, they need sunlight, water, carbon dioxide, and oxygen. That makes up 95% of their requirements. And then 5% comes from the soil in the form of macronutrients such as nitrogen, phosphorus, and potash. There are secondary and micronutrients, about 16 different types as well. But now it's important that both the nitrogen, phosphorus, and potash and the micronutrients which comes from the soil, it comes from natural sources. The carbon cycle which tells us energy can neither be created nor destroyed. So we have the plants growing their fruits, and through photosynthesis the carbohydrates and other structures are formed. These are eaten up by organisms which are both your animals and microanimals, and then also your microorganisms such as bacteria and fungi. Let's have a look how this happens at Varanashi Organic Farms and how we try to scientifically, using soil microbiology, improve the cycle, improve the speed of this cycle, thus giving us a high yield in through organic sustainable farming. So one of the crops that we grow is paddy, and one of the outcome from paddy is we have the paddy straw, and this again we use it as a feed for our cows. They eat them. Along with it, they also eat the green grass which we grow in our farm itself. And when they eat, they digest this the food in their stomach along with various microorganisms, while breaking down these organic matter. They are also producing methane. This methane can be trapped in a gobar gas unit, and that can be used for cooking and also in the production of electricity. And later, the spent slurry from this gobar gas also is a great nutrition for the plants. It's a great manure, and we inoculate them with some biofertilizers, beneficial microorganisms, and let them grow there, and then we put it out to the field, and we get great yield as well through this. So we saw the cows eating the fodder that comes from the farm as a byproduct of paddy cultivation, and when they eat them, obviously they digest them inside their stomach, and when they poop, the cow dung is collected over here, and it is sent down to this 15 cubic feet chamber, which has again two different chambers there. The anaerobic digestion happens there. So the cow dung is broken down to release methane. This methane is trapped under this tank, as you can see, and this trapped gas is sent to our kitchen through the pipe, and we use the biogas for all our cooking needs. We do not buy any gas cylinder from commercial cylinders. We use the methane produced by the gobar, the cow dung. And when the methane is burned, it is not harmful for the environment. The harmfulness of methane drops down to less than 1%. So that way it's environmentally friendly as well. And once the anaerobic digestion is completed over 40-45 days, the spent slurry comes out. Now this spent slurry is rich in nitrogen, phosphorus and potash, mostly nitrogen and phosphorus, and they are in more bioavailable form for the plant roots. So they're not in a complex form, they are more broken down, and they're more bioavailable as a fertilizer for our plants, for our plantation crops. So the excess spent slurry goes through a tank a little south of here through this pipe. So the spent slurry that you saw at the cow shed after the biogas preparation, it comes through the pipes from there to here, to this large tank here. This holds up to 1 lakh liters, and we inoculate a consortium of biofertilizers into this. There are the nitrogen fixers such as azospirillum, azotobacter, then rhizobium that we inoculate here. We have the phosphorus mobilizers such as Aspergillus niger, Bacillus megatherium, Bacillus subtilis, and we have Pseudomonas, which is also a biocontrol agent and also a phosphorus solubilizer that goes in here. And we also put Fracturia, which is potash mobilizer. So with all these microorganisms growing over here, and once it's brewed, we put it to our farm. So it goes straight in through the pipeline, through hoses. We put this liquid biofertilizers, which is rich in NPK and also microorganisms, which beneficial microorganisms, which help the uptake of nutrients into the roots. That goes straight into the farm, and thus it aids in the quick and fast development of the plant and also a higher yield. One of the major aspects in farming is also water management, water harvesting and water management. Excess water brings us diseases. At the same time, lack of water is also not a great thing for farmers. So we need to manage the water. One of the best way to manage them is by having a lot of these channels, drainage channels through the farm. And as we have more number of drainages or these channels, the water is made to touch more surface area in our farm. So they are taken zigzag, and also every 8 to 10 feet we have these drainages going, so you can come through. So there's one over there and another one is right here, and then about 10 feet later there is another drainage, there is another channel. So this water is made to touch as much surface area as possible in our farm. When it touches the surface area, this soil, it also, part of it also gets absorbed into the groundwater. And when the groundwater is enriched, the roots, which is again, we also give the roots the arbuscular mycorrhiza, the glomus species. This forms a mycelial network underground. It connects the two different roots of different plants, and they also help in the movement of water from one side to another, and it makes the water just available for all plants in different parts of the farm. So it's all integrated. You got to do rainwater harvesting, at the same time you got to use the different microorganisms out there which are beneficial in your plantation as well. What we have understood over a period of time, that it's always best to have multi-crop farming, so more than 4 or 5 different crops happening in your farm. We have learned that sunlight is the most important the food for the plants for their growth. So it's important that we harvest the sunlight in different levels. At the top we have, in this farm, at the top we have arecanut, coconut and jackfruit. So they are they're quite tall, and they capture the sunlight from that top part. And then as you come down, we have nutmeg, which is right behind me. And nutmeg also grows about, say, 20 feet in height. If arecanut goes up to 30 to 35 feet, your nutmeg goes about 20 feet high. And they capture the remaining sunlight, which is let off by the arecanut and coconut. And then you come down, we have banana. They have these large leaves which capture the remaining sunlight after coconut, arecanut, nutmeg, and then comes banana. And after banana, we have cacao in our farm. Right behind us, we see cacao, and cacao takes the remaining sunlight. So as you walk on the ground, there's hardly any sunlight falling in the ground. So we don't have the problem of weeds growing in the farm. At the same time, we have the leaf of cacao, we have the leaf of pepper, we have the leaf of nutmeg. We have the leaf of arecanut, and coconut, all of them falling into ground, and they getting eaten up by microorganisms, macroorganisms like the bugs and insects and centipedes initially, and then some animals, and then later on by various microorganisms which digest these organic matter into bioavailable nutrients that when we spoke about nitrogen, phosphorus, potash, and other micro and secondary nutrients. So all of this from the organic matter gets digested and back into the soil, which is ready to be absorbed by the roots through water and goes up again for photosynthesis, and we have the produce coming in. So this is a natural cycle that has been happening in our world for the last 450 million years. So we just need to identify that, and we have to aid it. We need to use science, use the soil microbiology, understand which microorganisms play the most important role in this digestion, and increase their colonies in our farm. So that way we are aiding the natural cycle, the natural carbon cycle, and we are getting high performance through sustainable way without using chemical fertilizers. A quick view of a multi-crop farm. On the top layer you can see the arecanut growing around, and the pepper vines are going on the arecanut tree. And then you come down a little bit, you see the nutmeg with the small but plentiful leaves over here. And if you just turn around the other side, we have cacao, and right at the back we have banana. So it's a kind of forest, but at the same time they're all commercial plants as well. They're all the ones which gives us food. Nutmeg is used as a spice. Pepper is a great superfood spice. Arecanut is a habitual crop, unfortunately. Banana is a food crop. Jackfruit is a food crop. And cacao is also a superfood if it's used properly as dark chocolates. It's highly nutritious. So, food forest. As we walk through this farm, we can see that we can hardly see any green leaves. Most of them are decomposing, and they're decomposing in a very fast way. Like the leaves do not stay green for more than a day. This is happening because the soil is alive with, like I said, millipedes, centipedes, earthworms, all these guys. There's a lot of these animals, little micro animals here. At the same time, we have also inoculated this place with a lot of biofertilizers, which eat up these organic matter very fast. So that way you can kind of tell a high performing organic farm or a sustainable farm, the fallen leaves, they get digested very fast. They decay very fast. With this decaying process, we can say that okay, the soil biology is good in a farm. It's an indicator. So one of the issues that farmers face is the growth of weed in their farm. So unfortunately, a lot of farmers go for weedicides, and they are highly poisonous, and they're not recommended as it kills the biology of the soil. But having said that, we do not have any weed in this farm. If you're wondering why, it is first because of multi-layer farming. We have 7 to 8 different crops growing in the same area. So what happens is the sunlight is consumed by these different layers of farming plants. So there is hardly any sunlight falling into the ground. So without the sunlight, there is no scope for the weeds to grow. Another thing is all these leaves which are falling down is covering the ground further, not allowing the sunlight to touch the ground. So there is no germination of weeds happening or the growth of weeds happening. So we do not have to use, we decide keeping the soil free from poison, and we are letting the soil biology improve every day and every month, every year and every decade. So one of the our favorite crop in this food forest is the jackfruit. The jackfruit is native to our country, and I'm not an expert in jackfruit. My parents have identified 64 different varieties of jackfruit, and they're growing in a mother plot in here. But I like a story about jackfruit, which is a part of our history, and which has helped us survive through the traumatizing times of our history. So in 1940s, there was a world war happening. At that time, India was still under the British rule, the English rule. That India was a colony, and at that time, the British thought the war would go for longer, and they started hoarding up food, they stocking up food. And all this food stock was coming from colonies of the empire. And from India, all the food was taken away to Britain. And from this area as well, we used to grow up to 10 tons of rice, which all the 10 tons of paddy was taken to Britain, and there was no food left in this area. At the same time, we had in places like West Bengal, millions of people starved to death. But in this area, people started eating jackfruit, and they lived off eating jackfruit because jackfruit is a huge fruit. It can grow, that big. It can be up to 15 to 20 kilos and can feed an entire family for days. So jackfruit is really sacred for us. There are different varieties of jackfruit. The speciality of jackfruit is no two jackfruits are of the same variety. There's always something to look forward in taste and flavor and texture. And today the jackfruit seed is going as a gluten-free food replacement, and there's a huge market for it coming up. If cultivated well, jackfruit could be a great permaculture crop, food forest crop. We have all heard the mantra of rainwater harvesting or water harvesting. So we make the running water to walk, walking water to crawl, crawling water to stop, and the stop water to seep into the ground. So as the rainy season slows down, as the streams thin down, we put check dams such as this. It's the very simple man-made check dams can be constructed in a couple of hours with 2 or 3 people, and this starts blocking water. Excess water is allowed to flow out, and whatever it's blocked, it retains in our farmland and also percolates into the ground. While it's percolating into the ground, it forms an underground water network. Say underneath, imagine a river passing through, but very slowly. On the top of the ground, the water moves very fast. It travels in the speed, in meters per second speed. But in underground, it travels, say, meters per 2-3 months. So the movement of the water becomes very slow, and it can be tapped by the roots, or even if you are gonna drill a well, that water can be tapped back. The trapped water can be tapped back for the farms. Crops that we have in plenty is cacao. In Greek, it's called Theobroma cacao. Theobroma stands for food of gods. So it originally comes from Latin America, but it's been in India for over hundreds of years. It came to South India through Camco and CPCRI in the late 60s. And there are 3 varieties in cacao. So the pure blood is called Criollo, which is a quite expensive variety. Unfortunately, it's not there in India anymore. We have the Trinitario, which is like a hybrid between Forastero, which is a wild variety, the 3rd variety, Forastero, and then the Trinitario and the Criollo. In this farm we have Forastero and some Trinitario. The Forester is more round in shape. It's the wild variety. You have plenty of yield in that, and also it's quite disease tolerant. And then the Trinitario is slightly sharper, and it has ridgy sides. So that's how you differentiate between the Trinitario and Forastero. Now cacao, it's also called as cocoa. It's used in the making of chocolates. So the nut inside is fermented for 7 days and sun-dried for about 7 days, and it is sent out to the chocolate factories where it goes through various processes and they make chocolate out of it. But although your doctor might say chocolate is not good for you kids, but I would say as a swimming coach, high performance swimming coach, I would say dark chocolates, less processed chocolates is great for you. This is because the nut, the cacao nut, is filled with nutrients which are essential for not only the body but also for the mind. Now the cacao nut has theobromine as one of the components, and also tryptophan. Now theobromine is similar to caffeine. It keeps you awake, but it's a slow release and it keeps you awake for longer time. So up to 6 hours it keeps you awake so you can do your work. And then there is tryptophan. Now tryptophan is a precursor for dopamine. It produces serotonin, which is a precursor for dopamine. Now dopamine keeps us happy and active and quite engaged with our work. In terms of nutrients for the body, it has magnesium, it has zinc, it has calcium, it has phosphorus, many of the nutrients which are hard to come by in vegetarian diet. This is packed with that nutrients. So cacao is no wonder called as the food of gods, or theobroma. And we are really happy to have it in South India and in our farm. It's a great crop for permaculture. It goes really well with areca nut, nutmeg, coconut, jackfruit, as it takes up the lower part of the multi-layer crop system. So there is a story about this borewell. We have total 3 borewells in our property. All of them are over 20 years old. This was one of the first borewells we had. It's about 120 feet deep, and we never used to have water in this borewell. But about 20 years ago, my father, Dr. Varanashi, he started recharging the borewell. You can see as the rain subsides, we put a bund to it, like a small dam, mini dam, which allows the water to stagnate around the borewell. Also, on top of that, we recharge the borewell with water going inside through this pipe, and it's a constant process. Whenever there is excess water in the farm, the outgoing water is sent back into the borewell, and from March onwards we start using the borewell for 3 to 4 months, and we've never had water shortage in this borewell ever. So borewell recharging is a great novel concept, and it should be used everywhere, and it gives results. So quite interesting stuff happening here. We have the good folks from Desha Forum and Satya Consultancies. They're building houses using mud. So how they do it is they take the mud, they mix it up with lime, and they let it ferment for a week. So the mixture of 10:1 mud and lime is mixed, and it's mixed well, and it's let to ferment for a week. And after a week, they add the equal amounts of 1:1 amounts of coir by volume, and then they mix it again well, and that goes as a building material for the mud houses. So here we have the mud, fermented mud and lime mix, again mixed with the coir, 1:1 coir. So this blocks chunks are used as construction material for the mud walls. So this way of construction is called as the wattle and daub principle. So we use bamboo for the reinforcement structure inside, and after that the mix of lime, mud and coir is placed on top. So as it dries off, it becomes really hard and it becomes It's not a weight-bearing structure, but it's a good wall material. And we're going to build some cottages using this. It's very eco-friendly, carbon footprint super low, very low, and at the same time it lasts long, and it's a great, it keeps the house cool during summer and warm during winter as well. The heat thermal insulation is really good with this method, and it also looks lovely, I think. So here we can see the different types of plastering that was done as an experiment by the Desha Forum and the Satya Consultant group, and it's basically a mixture of sand, cow dung, mud, lime and glass pieces, and these are all various different mixes. You can just have a look, and this is just an experimental block, but I think we're going to choose this. I really like that, and this as well as a plastering for this material. So once this dries up, this will be the plastering through and through, and this is waterproof as well. Again, made completely using natural materials. There is zero cement used. And we use recycled materials such as glass, and then pieces of metal pieces, so upcycling as much as possible, at the same time aesthetically looking quite nice as well. Usually if you go to a construction site, you'll see a lot of metal pieces and not natural materials that are lying around, but here you see most of the stuff lying around is natural materials, so the footprint is quite low, I can say. So here's an example for a man-made structure. It's a plastic lined tank. We use the plastic lining because our soil doesn't hold water, so it acts as a tank. Now the structure is completely made from mud, again mud and rocks, and on top of that we put the plastic lining. So this is called rhino mat, and we also get certain subsidy from the horticulture department, from the government, to have these structures, and they're great as water tanks, and they're used for irrigation. So another thing what we do here is we inoculate these tanks with effective microorganisms. Now effective microorganisms are basically a consortium of bacillus species bacteria, photosynthetic bacteria and some fungi. They help in the degradation of organic matter. They keep the water clean, and also they make the organic matter in the water more bioavailable for the plants. And when we use this for irrigation, it gets into the soil and also further helps the decay and degradation of nutrients from complex form to the more bioavailable form for the roots.